question. Is that nasty as an exam question? Is it okay after all we've been doing so far? So it's an example of like a knapsack problem of the sort that we've been doing. I guess that we started with how many things to take on board, or how many things to steal for the burglar and things like that. So it's a similar one. Once you identify that, it shouldn't be too hard to solve. So what do you want as your decision variables? Anybody?
XE, whether you take an experiment or not. Binary.
XE, so this is 1 if we take experiment E.
Yeah.
Then not curly E, and it's 0 otherwise. Yeah. Do you want any other variables? No? Yeah, so I guess. So the objective just for part. Yeah, okay, we're just doing part A, I guess. Well, it's somehow, somewhere it gives the objective away, isn't it? You want to maximize revenue. So it's to maximize the revenue, and the revenue, well, every single experiment has revenue R sub E. So let's do a bit more. Given up there. And you count it if you're doing the experiment and you're not, and you're counting 0 if you're not doing the experiment, and you just have to add them all up. So that's the objective. How are the constraints? So we have weight and we have required electric current for each of these experiments. And we must not exceed the total weight, and we must not exceed the total electric current. So the weight constraint, the total weight we're taking is WE times XE, added all together. Is it not? And that must not be more than the total weight, or whatever it's called. Yes. And then for current, it's a similar one. And we want all the variables to be binary, and I guess that's everything. So part A. Any questions or objections? Comments? Improvements? No? Okay. How about part B?
New decision variable Y.
Okay, XE as before. I should say decision variables. You want why?
Yeah, whether you take the battery or not.
Yeah. Just thinking which variant, but there was once a variant where you were allowed to take more battery packs than one, but here you're only allowed to take one, I think, to protect them. So again, that's a 0, 1. 1 if battery pack is taken and is 0 otherwise. Do we need to change the objective? No. There's no cost of the battery. There's no revenue of the battery either. So the objective remains the same. The constraints change, right? Because the weight, now we have to count with the weight of the battery. So we have W bat times Y plus the weight that we had before. So that was W of each experiment added all together. That must not be more than total weight allowed. Okay. But the current constraint, so the current that is required is still the same. And the current that is now available is, is increased by I bat if we decide to take the battery. Does that make sense?
It should be IXC on the left hand side of that current one.
Oh, yes. It should be. Thank you. Two questions. Okay. So that's kind of good. And then we still have XE is binary, that's the same as before, but also we have that Y is a binary decision variable. That's it. So you see, in 10 minutes, if you know what you're doing, you can answer. I don't think that was quite the full 20 marks, or maybe 15 or something. It's not very hard. But students somehow, I don't know why, they find these formulation questions either hard or nasty, or I don't know. I've never understood exactly why. Maybe because it doesn't follow like a set procedure. Because if somebody gives you a simplex method and you know exactly what to do and you just do it kind of mindlessly, whereas with this you have to think about it a bit more. But is that okay? But because practice makes perfect, I've got one more. And then because I'm getting bored of them, I'll probably can do some past so exam questions from last year and from next week on. Too much revision. Has everybody got a handout? Yeah. So take some time to read the question, and then we'll solve it. Okay, ready? Ish. So, does anybody want to guess what kind of decision variables we'll be looking at in general terms? Okay, so the question wants you to make a timetable. What is a timetable? Well, a timetable is a kind of an assignment where you have a lesson for a certain class. It has to go into one of the time slots that are provided. Okay? So you're assigning a time slot to every combination of class and lesson. And if you want to do it using integer programming, then arguably the best way is to have a 0, 1 variable for each combination of time slot, lesson, class. And that will then tell you whether that particular teacher is taking that particular class in that particular time slot. That's the basic idea of doing it using integer programming. Then it's just a matter of expressing all those constraints that are given in words as constraints in those 0, 1 variables. So that's to it. Okay, so first let's just get a summary of what the data are that we have, or what we know. So we can write the formulation. Well, we have a set of teachers. What do you want to call it? T? There are about 10 of them. But yeah. Then we have a set of classes. There are 2 of them. So it's 1 and 2. And then we have a set of time slots. And every decision variable will have these 3 indices. So it'll be like a 3-dimensional array once you start writing the code. So this is the set of time slots. And for the time slots, it would be good to number them by numbers 1 to 20. We could do that for the teachers as well, 1 to 2. So we'll take the time slots to be the numbers from 1 to 20, and then the calendar looks like this. So what do we have? We have 4 time slots every day, and we have 5 weekdays. And the time slots are what? 8 to 10, and there's 10:15 to 12:15. Wow. And there's 14 to 16, and then there's 16:15 to 18:15, and 12:15 to 12:15. And then we have the 5 days of the week. So your numbering would be to do 1, 2, 3, 4, 5, 6, 7, 8, and so on. And the last one is 20. Okay, and then the last thing we know is the number of lessons. So let's call it NTC. That's the number of lessons given by teacher T to class little c. So these are the numbers in the 2 columns in the table. Everybody okay with that? More or less. So the decision variables are as I said. What do you want to call them? X? Yeah, again. Okay. So we will have, for each triple of teacher, class, and time slot, we will have a 0, 1 decision variable. And this is going to be equal to 1 if teacher T takes class C, which is 1 or 2, in time slot S. So that's 360 decision variables, because there are 9 teachers times 2 classes times 20 time slots. And each of them can be 0 or 1. That's everything we need. So, constraints. Any constraints?
You can just put in the individual time slots that they can't happen.
Okay, the slots that can't happen, or the slots that have to happen, or something like that.
Well, you can do both, obviously, but there's one.
Okay, yeah.
Like,
Okay, so you mean something like Thursday afternoon has to be sport?
Yeah, or Monday morning, first lesson. No.
Nothing. Is that there? I can't remember. Oh, yeah, okay. Okay, yeah, so the first one, let's go through them one by one. Okay, so the sport lessons have to be on Thursday from 2 to 4. And I think that is, so this is 11, this is 16. No, this is 15. So that's in time slot 15. So, so X, which teacher is it? Muscle. Class 1 and time slot 15, did I say? Has to be 1. And the other one is that we have biceps. Class 2, slot 15, has to be 1. So that's how you say this particular teacher, this particular class has to happen in time slot 15. Okay. We'll have another constraint that will make sure that it doesn't happen again. But there will be a general one for that. But yeah, what we could do is also put a 0 for all the other time slots, but it won't be necessary. Okay, is everybody happy about that? So the next one says that the first time slot on Monday morning, you cannot schedule anything. Well, it might have been a smarter way of dealing with it by not even defining time slot 1, but now I've defined it. So I'm not having the decision variables for that time slot at all. But now I've defined it, so I have to give a constraint. So no teacher, no class can be 1 in teacher, class, and time slot 1. That they all have to be 0. Okay. Okay, then the next one says that f of x cannot do Monday mornings. Yeah. So that would be something like no class. And for the time slots, so Monday morning, that's 1 and 2. X of that teacher, any class, and time slot 1 or 2 has to be 0. These are kind of the not very interesting constraints because they're very particular. But let's get them done first. And then there's another one which says that insulin does not work on Wednesday. Okay, so no class, no time slot. What are the Wednesday time slots? They go from 9 to 12. So 9, 10, 11, and 12. No class, none of these time slots can be 1. Okay, so these are the specific ones. There should be some like more general ones because we know that we have to have a specific number of lessons for each of the classes, each of the teachers given in the table. Okay, so that should be satisfied. So something has to be the required number of classes given by teacher T to class C. What's that something?
Sum of CC.
And I want to add it over all the time slots. So this is going to give me the number of ones I have among them. And I want this for every teacher and for every class. Is this one clear? For every combination of teacher and class, I want an exact number of ones among the x's, which are given in this table. So it's the 1, 3, 2, and so on. I just call them big N, or the number of classes. Okay. Now, what are the typical timetabling constraints that make everything hard?
Need one that says that you can only use time slot once.
Exactly. So, well, you can only use the time slot once for what?
For each class.
For each class. Yes. So you can't have a class do 2 lessons at the same time. Okay. So yeah, that's an important one because so for every class and for every time slot, you want them to have no more than one teacher assigned in that specific time slot. Okay, so when I look at all the XTCS, so fixed C and fixed S, well, I have to do the sum over all the teachers. So this is the number, this sum gives me the number of lessons assigned to class C in a specific time slot S, and I don't want them to have more than one. Make sense? Yeah. I want a similar one for the teachers because they can't teach two classes at once either, can they? So I also want for all teachers in every time slot, when I add all the classes they teach, that shouldn't be more than one. Like in bigger time-saving problems, like at this university, for example, you would normally have teacher class or teacher students, I don't know what unit, time slot. You would also have the rooms. So this problem is kind of easy. It doesn't, well, easier than many of those real-life problems, but I don't know. So there might be another constraint if we were assigning rooms as well. There might be another constraint that you can't have two different lessons in one room at the same time, but we don't have that in this example, so that's easy. Well, and then, sorry, there's another constraint in there which says that, what was it? Every class may only have one lesson per subject on a single day. So how do you write that?
You have to split the times into day.
You could do that, but it's possible to write it in a more compressed way. You just have to say, so okay, so how do I want to number my days? If I number my days, I think, well, you could number the days 1, 2, 3, 4, 5, but in this case, it's the formula gets easier if you start numbering them from 0. So if Monday is 0, Tuesday is 1, and Friday is 4. So on every day, for every class, for every teacher, you want at most one lesson for that combination. Okay? So the time slots will go from, I think, D plus 1. No, sorry. Again. So what are the time slots on a specific day? We've got the table. So on Monday, I'm going from 1 to 4. On Tuesday, I'm going from 5 to 8. So every day starts like 4 slots later than the previous day. So what I need to do is start from 4D plus 1, yeah, which for Monday, it gives me 1. For Tuesday, it gives me 5. The next one is 9. For Friday, it gives me 17. And the last slot is 4D plus 4, or 4 times D plus 1. Sorry, that's the last slot on day D. And That should be no more than one. Yeah, that clear? Any questions about this? So the sum just goes through all the time slots on a specific day, and you have to work out how to address them using the data. There's nothing deep about that at all. Yeah, I think that covers all the constraints that are given in the problem. But we shouldn't forget that we want all the decision variables to be binary. Any questions? Well, now you can go and write the Mosul code, except you don't have to because I've put it in there. But if you're interested in seeing how that translates into computer code, you can download it and have a look at it. Your homework problem is, I think it was another exam question at some point, quite an easy one, so maybe half a question or something. You've got some reading about how to do logical constraints, which we sort of have been doing all along, but it's just a summary. And yeah, I'll probably send some exam questions to have a look at before we do the revisions from next week. See you all later.